Good morning, everyone. This is Lori DeToro from Fluke Excelix. Thank you for joining us for this month's Best Practice webinar. As software and sensor providers, we offer an array of webinars and other education, including product demos and product training. Our Best Practice webinar series focuses not on our technology and software, but on maintenance strategies and solutions with speakers from a variety of backgrounds to share their knowledge. We are really pleased to have with us today John Bernet, Mechanical Application Specialist with Fluke, who will be presenting how to combine vibration monitoring with other sensor technologies. John is also one of the experts on our Facebook community, the Maintenance and Reliability Academy, where you can ask questions and get info on all maintenance and reliability topics. Good morning, John. Thanks so much for joining us today.
Good morning.
Before you get started with your presentation, I wanted to ask you if you can tell us some of the major types of condition monitoring technologies that can be leveraged in today's facilities.
Sure. There's really five, and so the first one is vibration, which is best for looking for mechanical faults in rotating machines. Then there's thermography, which is best for screening and supplementing three things: mechanical faults, electrical faults, and process problems. And then there's ultrasound, which is best for air and gas leaks, bearing lubrication and steam traps. And then number four, oil analysis, which is best for problems with the oil, as in lubrication and cleanliness and wear particles in the oil. And then finally, motor testing, which is best for motor electrical problems.
Great. Thanks so much, John. We're excited to hear your presentation. And before you start, we have a few housekeeping items to go over. Today's session is being recorded, so the phone lines are muted to minimize background noise, and we will save time after the presentation for your questions. You can use the questions feature on GoToWebinar to submit your questions and comments at any time during the presentation, and I will read them to John so that he can respond in our Q&A at the end of the presentation. So I'll hold all questions until then. If you'd like to receive a copy of today's presentation, the slides, please let us know during the survey that will appear at the end of today's session. And the recorded webinar will be available on the excelix.com/community, the Excelix community. And I think that's it for housekeeping items. Again, if you have questions, ask them at any time using the question feature, and we'll ask them at the end. And John, I think we're ready to get started.
Okay, thanks, Lori. Let's get rolling. So first of all, real quick introduction of myself. I've been with Fluke for about a little over 7 years now. I started my career in the U.S. Navy, where I spent 12 years in the Navy, where I maintained and operated nuclear power plants for the Navy. And then I went to work for Azima DLI for 18 years. They're vibration analysis consultants. And I learned to work with a lot of customers setting up reliability programs. And then I came to Fluke. So about 30 years of maintenance and reliability. So let's talk a little bit about some of the challenges that I've seen over the years and some of the things that some of our customers have faced. And let's talk a little bit about how we can come up with some solutions for some of these. So over the past few years, we've seen the challenges that really aren't that different from the challenges we've seen in the past. But what we're seeing is one common problem, and that is that maintenance teams are having to do more with less, all while the cost of downtime is getting worse and worse. Excuse me. And we found that there's really three main problems to this, and one is the shifting workforce, which there's basically a lot of the skilled experts are retiring and they're not being backfilled, which has given us a large skills gap. The second thing is, over the years, machinery just keeps getting more and more complex, where you've got a lot of motors that are now variable speed drive. You've got a lot of more complex machines that are computer driven and computer operated, and just like our cars, everything is getting more and more complicated. And then finally, budgets. We're having to do more and more with less and less, and it seems like not only has the economy had a problem, and we've had a lot of company-wide constraints, but it also seems like sometimes the budgets will go away, and when a program fails, then you don't have any more budget at all. So these things just keep making things harder and harder to face. So what do maintenance teams do? And what we've been doing is we've been talking to maintenance teams. We've been trying to talk about being more proactive. In an ideal world, that's a great idea. And for the past 30 years, we've been talking about proactive maintenance, and basically everybody wants to do this. Everybody wants safer workplaces, more uptime, more profits, be able to extend machine life, have better predictable schedules. But in the real world, that just doesn't seem to happen. Things always get in the way. So we're kind of left with three choices, and all of them are bad. One of them is to be reactive, where we just run machines until they fail. But in today's environment and today's economy, that just isn't practical. We just can't do that anymore. It just, everybody is talking about, we've got to find a better way to run the plant. Preventive maintenance, where we repair machines based on the calendar, and that's been around for 40 years or more. And studies done back in the 60s by the U.S. Navy and the airline industries, and almost every industry since have confirmed that on rotating machinery, doing a calendar-based maintenance just isn't very effective. As a matter of fact, only 15% of machines of repairs, really do anything, because what we found over the years is that machines fail randomly no matter what kind of calendar-based maintenance we do. So what do? And a lot of people have tried to go to a more predictive, where we condition-based maintenance, where we trend and repair machines only when needed, which again is a great idea, but how do you implement these programs when you're already too busy? And so everybody has these same problems of how do we make things better when we don't have any time, we don't have any resources, and we have too many machines. So teams have to a point where they say, how do we choose between these three choices, which are all hard to do and hard to maintain? Well, there are some ways that we can learn from some others and learn who's been successful and how they've done that. So let's look into what other people have been successful for, and let's see if we can come up with some ideas. So the top 8 questions that maintenance teams have asked, and that's what we're going to go over, is how do you monitor all your critical machines with fewer resources? How do you bridge the skills gap? Why do we keep replacing the same bearings and seals? What tools do I start with? How do I get the benefits of proactive maintenance when, without starting up a big program? How do I justify the cost of tools and resources that are needed? And how do I start up a program when I'm already 100% busy with PMs and fixing machines? And then finally, how do I restart or start a program? So we're going to look at each of these, and we're going to look at this from a point of view of what some maintenance teams have found to be solutions to overcome these challenges. So let's share some best practices with you of what others have found to be successful. So the first question, how do I monitor all the critical assets in our plant when we just don't have the resources? We just don't have the labor, we don't have the skills, we don't have the time, we don't have the money. Well, why don't we look at other industries to find out how they've done it? And if we look at the medical industry, for example, they have the same problem. They've got millions of patients, and they're all critical. Not one patient is more important than another. So how do you do that with a limited number of specialists? So what they do is they do a tiered approach where they use nurses that take a quick test, and a nurse will check your blood pressure, pulse, and temperature and find out with some quick tests whether you need to see the doctor or not. When you see the doctor is able to quickly look for the most common problems. They're not going to spend a lot of time looking for the really obscure things. They're going to look for the colds and the flus and the broken bones and the viruses and the things that happen every day, because the odds are that's probably what the problem is. And if we can take care of those common problems first, then we don't have to send out to see a specialist. Well, why don't we do the same thing with our rotating machines? Why don't we screen our machines with simple tests, just like the nurse screens out a patient to find out whether it's healthy or not, and before we call in the doctor and have the doctor find problems before we call in the specialist for our machines. So the benefits of doing a tiered approach on our machines is, number one, we don't spend time analyzing healthy machines. That's a complete waste of time. And we don't want to deploy experts for simple faults on simple machines. So let's talk a little bit more about this. So the solution of monitoring critical assets with fewer resources is to use a tiered approach. First, we want to screen out which machines are healthy and which ones aren't, and then diagnose the most common problems, and then send just the most specialized or most complex problems to our experts. So let's dig a little deeper into that. So how do we bridge the skills gap? So if you think about it, if you look at a plant, we can break a plant up into three major categories. There's kind of the top tier, which is just a few machines, your paper machine, your machining tools, your main turbine, very complex machines that you need an expert to basically babysit that machine. Then below that, you've got thousands or at least hundreds of very critical vital machines, but they're pretty standard machines. Standard motors, pumps, fans, compressors, and blowers. These are the meat and potato of the plant, and these are the ones that the maintenance team need help to keep running. And at the bottom tier are thousands of non-vital pumps and motors and fans and that kind of stuff. So once we kind of realize what kind of machines we have in our plant, let's look at a simple flow path to kind of help us bridge the skills gap. So instead of calling in an expert for all of our problems on all of our machines, because we just don't have the resources, let's screen our machines. Because if we can screen our machines and find out which machines are good and bad, that's going to screen out about 80% of the machines, because traditionally 80% of the machines in the plant are healthy. So why analyze a healthy machine? That means we've only got 20%. So right off the bat, we've knocked out 80% of the things, so we're only looking at 20%. Of the 20%, let's look for the most common problems. Just like the doctor looked for the most common problems before we went to the specialist, there really are four main problems with rotating machinery: imbalance, misalignment, bearings, and looseness. So why don't we look for the most common problems that are easy for a technician to fix instead of looking for the most obscure things first? Because 90% of the problems with a machine are those four main faults, which are easy to fix. And that means we've only got 10% left over. And of that 10%, then we call in a specialist. So screen out 80%, which are healthy, and you get left with 20%. Of that 20%, 90% of them are very easy. And so if we can screen things out at the lowest level, then we can save ourselves a lot of time and a lot of resources. And that's how we bridge the skills gap, is by using the right tool with the right skill level and the right person with the right training. So let's talk a little bit more about that. The next thing we want to talk about is, why do we keep replacing the same bearings and seals? And when I talk to customers all over the world and in every industry, they have the same problems. That's because the real root problem is deeper than than the bearings. The bearings and seals are just the symptom. The real problem is imbalance and misalignment and looseness. Over the years, we found that 50% of rotating machines, the problems are really due to misalignment, and most people just ignore it because it's just either too hard or takes too much time or it's too complicated. And if we just leave it, all it's going to do is it's going to transfer those forces to the bearings and seals, and we just keep replacing bearings and seals. So how do we fix this? Well, just like the medical industry has learned to do, is we need to fix the problem, not the symptom. The first step is we need to find the problem. So diagnostic testers help us find all the problems, not just the bearings and the seals, but misalignment and imbalance and looseness. And by leaving these, even in a moderate or not a very serious level, is going to increase. So if all we do is keep replacing bearings and seals and ignore the imbalance and misalignment, we're just going to keep repeating this over and over again. The second step of it is there are nice, easy to use alignment tools that provide not just quick and easy, but precise alignments in a fraction of the time. This allows us to, with minimal resources, be able to align all of our machines in the plant, not just a few. So the answer to the problem is let's quit replacing bearings and seals, and we need to start finding the root cause and then use tools that can help us fix the root cause, not just fix the symptom. All right, number 4, what tools do we begin with? Well, we've kind of already talked a little bit about this. So there are really 4 steps in condition maintenance. Step number 1 is screening. So if you look at this, we can use simple screening tools, and the screening tool is going to tell us within a matter of just seconds which machines are good or bad. So if you see in this example down at the bottom, you can see that on our smartphone, it's telling us that we've got a machine that's in the red. So it's pretty easy to tell either the machine is green or the machine is yellow, orange, or red. So in this case, we've got a machine in the red, so it's time to bring in the doctor. So step number 2, we bring in the doctor, which is the vibration tester or the thermal imager. And with the doctor, we're going to be able to get a diagnosis and, more importantly, a recommendation. So in step 1, we found out the machine was bad. In step 2, we find out that it has serious misalignment, and the recommendation is to align the machine. So instead of just ignoring the alignment, we need to fix it. So that's when it's time to call in the surgeon. So when we call in the surgeon, in this case, we have quick and easy, precise laser alignment tools now that a technician can use. You don't have to be an alignment expert. And these tools, in just a matter of 15 or 20 minutes, can take a simple standard machine and help you step by step correct the alignment. And so here we see in the first slide, as found, that the vertical and the horizontal alignment was in the red. And down below, we can see that after 15 or 20 minutes, we were able to correct the misalignment, and now it's in the green. So we found a problem, we diagnosed the problem, we corrected the problem. And before we turn the machine over and put it back into service, we need to check and make sure we fixed the problem. So again, bring out your screening tools, and these quick and easy screening tools are going to be able to check to make sure the machine is good before we return it to service. And then we're going to track that machine using wireless sensors and other tools to be able to track the machine health over time so we know when it gets bad again. So again, start with simple screening tools and then match the right tool to the right failure mode. We're going to talk about that in just a couple of slides. Okay. Number 5 question is, how do I get the benefits of proactive maintenance without a big program? Well, the answer to that many of our customers have found that are successful, what they tell us is you need to get answers from the data. You need answers from the report. So when you look at your reports, you need to look for 4 things. Number 1, when I set up the tool, is it set up correctly? Number two, when I take my measurements, am I getting good data? Am I getting good results? Because garbage in is garbage out. Number three, am I getting answers from the data? Because if I'm just getting a bunch of numbers, numbers don't tell me a thing. I need to know what's wrong with the machine. And number four, do I have an action step? So I need to know, am I getting good data? Do I have a good setup? Am I getting answers? And am I getting an action step? So at the bottom, you can see where I've shown you the vibration screening tools, both a portable walk-around screening tool and a vibration wireless sensor. You can see down at the bottom, it's a little hard to see, but we're pointing out where these four answers are available in the report. The setup, the measure, the answers from the diagnosis, and the action steps are all in these reports from screening tools. Number two, from the diagnostic tools, the same thing. From the diagnostic tool, we want to know, is it set up? Is it measured correctly? Am I getting good data? And am I getting an answer? But more importantly, is it telling me what to do to fix this machine? And then laser alignment, the same thing. Do I have good setup, good data? And is it giving me the good step-by-step I need to be able to correct the alignment and get this machine fixed? But not only vibration tools, but we also need to look at thermal tools and electrical tools, because there really are three different types of tools: mechanical, thermal, and electrical, and all of them we need to get answers from. We need good setup, we need good data, we need a good answer, and we need a good action step. Okay, so question number six is, how do we justify the cost? Everybody understands we want to be more proactive, but how do I justify the cost? Well, there's a lot of cost savings, and most of this we've seen. Sometimes it's a little bit hard to get these ROI numbers, but basically here's the main savings. Downtime cost, energy waste. A lot of people don't think about energy. If you've got a machine that's misaligned or imbalanced, not only is it wearing the bearings and the seals faster, it's also using up a lot of energy. Replacement cost, labor cost, outsourcing, all of these are expensive. So we need to find a way to save money. Well, so this is part of the justification. And tiered approach allows us to get a higher ROI with lower risk. We don't have to invest as much in today's smart tools that provide answers. The good news is the tools are getting smarter, and the tools are getting less expensive, and they're providing answers, not just a bunch of data. So how do we justify? So another thing we can think about as we start to justify these programs, and we'll talk a little bit more about these later, is maybe using a pilot program. Okay, so let's talk about how to start a program when we're already busy. One of the biggest challenges that I've seen customers face when I go out and visit customers is they tell me, hey, we're already busy. There's no way that we can take the time to start trending. Well, the answer is start small and grow. Start with a pilot program. Don't try to do all of the machines in your plant at once. That's the number one recipe for a failed program. So the answer is, let's start on just 25 to 30 machines, and let's get a few successes. Let's get a few things that we can document, some saves. The good news is, if we get a few saves, if we can reduce some PMs, if we can reduce some repairs, there's your ROI, there's your cost justification. So if we can start with a few machines, get a few saves, then we can get some buy-in and we can get this thing going. Down at the bottom of the page, wireless sensors. If we don't have the resources to go out and use a portable tool, maybe the answer is to start using some of the wireless sensors. And so we're seeing these low-cost wireless sensors come into market now that's going to enable us to get into remote applications and also be able to provide answers on machines and we don't have to use the resources that we don't have. Okay, so those are some answers that some of our customers have come up with to help us to be able to start small, get a few successes, get a program going, reevaluate it over time, and get it going. So that gets us into our last question, which is a little bit of a review. So how do I start or restart a proactive maintenance program? And step number one we just talked about, and that is start small. The number one failure mode of a program is to start too big. If you start too big, you're still setting up the program when people are asking for results and the program is canceled. So the answer is start small and grow. The number two problem with starting up or restarting a program is getting just one tool and trying to do everything with it. It's like the old adage, if all you have is a hammer, everything looks like a nail. Well, in the maintenance world, you can't do everything with a thermal camera. You can't do everything with an electrical tool. You can't do everything with a mechanical tool. So you need to use some screening tools in those three different technologies instead of just trying to use one tool to do everything. It just doesn't work. And then problem number three is data overload. Once you start collecting a bunch of data from a lot of tools, if that data doesn't give you an answer, the program will quickly die. So the answer is, I need to get answers from my data, not just a bunch of numbers. So let's talk about these things. Okay, so how can I use vibration, thermography, and electrical tools to help complete your package? So we're going to show you in a couple of slides that there's really three different things we need to look at. We can't just look at electrical. We can't look at just mechanical or thermal. We need to use all three of these approaches. And then the second thing we need to look at is we can't just use high-end analysis tools. We need to use a tiered approach, just like the medical industry. We need to have screening tools and diagnostic tools and analysis tools. And then on top of that, we need to share this information. So this image shows on the left where we have portable tools, and over on the right is wireless tools. So now that wireless tools are coming in the market, and we have this great communication explosion and information explosion that's been happening for the past few years, now we can start putting wireless sensors and use wireless sensors and portable sensors together, get the information, get the answers, and get that up to the people that can use it. Get it up into work order maintenance programs, get it into analysis programs, get it into condition monitoring, and be able to get the information to the right people to be able to fix our machines and keep the plant running. So let's talk a little bit about some things that we can help you on your journey to world-class maintenance with limited resources. So let's talk a little bit about ROI, because the question everybody asks is, I need some ROI numbers for my industry. Next, we're going to talk about expected failure modes, and then finally, three pillars to program success. So when we have people asking us about ROI for their industry, the problem that we run into is that it's hard to get that information in today's environment where it's very competitive. So competitors don't want to share their ROI numbers because that's going to give away the competitive advantage. The second problem is security. The company doesn't want to let any of that information out because it's secure. And so even though we would love to be able to get these case studies from customers that are successful, customers just aren't willing to share that information. And I know it would make things easy for customers to be able to justify it. So instead of giving specific industry-specific applications and case studies, we can share some of these more general case studies, and then you'll probably have to start with a pilot program to be able to prove it in your plant. So here's 3 different case studies over the years, and there's literally hundreds of different case studies, but to find one for your specific industry, your specific machine type is going to be tough to do because people just aren't sharing that information. So number one is a general study done by the Electric Power Research Institute many years ago that showed that across all industries, that trending or condition-based maintenance is 47% cost savings over run to failure maintenance. Everybody has seen that study. It's very common. But it's pretty global. Number two is showing a classic example of a large company that started a predictive maintenance program on simple motors, pumps, fans, compressors, and blowers. And over 25 years, they documented their saves where they saved literally millions of dollars every year based on the benefits that we see down here they tracked. And every 2 years, they would do a cost of benefit study and they would document their savings that averaged over 20 to 1, which meant that every dollar they put into reliability saved them $20. So these are examples of case studies. One at the bottom is a case study from a small company that over 16 years went from reactive to preventive to predictive. And of their 600 critical motor pumps, they were able to cut their maintenance budget in half over 10 years. Their machines were running twice as long, and they eliminated all downtime and all overtime. So there's a lot of examples of these case studies. The difficult part is getting numbers exactly for your machine and your application. Now, from a vibration standpoint, rotating machines just aren't that different from each other. I know that a lot of people feel their machines are very specific and very unique, but when you're looking for the common faults on a rotating machine, every machine really is the same thing. It's a rotating motor shaft with a couple of bearings, a rotating pump, fan, compressor with a couple of bearings, and then a coupling or a belt in between. When you're looking for imbalance and misalignment, that's really all a machine is from a vibration standpoint. So if you look at different types of machines by industry, that you'll see that of the categories that we talked about, so there's different applications in different machines. Again, at the top of the machine pyramid are a few very complex machines that you really need a vibration expert to babysit that machine. But in most plants, you'll see that there are some critical machines that are very standard machines, then tier 3, which are critical and very standard, and then non-vital. And if you look over on the left, you can see how we can break that up by industries, that there's really only 1 or 2 industries that you have a lot of very unique and critical machines, like the wind turbine industry, where most of the machines are very critical and very specific and very complex, and you really need a vibration expert. But in most industries, you can see, like water and wastewater, for example, there are literally no complex machines. Every machine in the plant is a simple standard machine that a basic vibration tester and screening tool can find the answers. In food and beverage, there's a few machines that are complex, and in paper machines and in machining tools, there's a few machines. So this is bringing us to the point where, in general terms, there's 90 or 95% of the machines in a plant can be done by a technician using simple, smart tools that give you answers. Okay, one thing we want to look at, and maybe this is a better indicator or a better starting point, is what are your expected failure modes? And so when we start looking at what tools we need, we really should be looking at what kind of faults are we expecting to see. So this is our introduction question that Lori asked, and that is, which technologies do we start with? If you look at the screen, I know there's a lot of information here, but let me boil it down to a couple things. Over on the left are your failure modes that we see in almost all industries. And then here in the middle are the different technologies that we would use: oil analysis, ultrasound, vibration, motor testing, and thermography. And then over on the right is the correction. So what we recommend is you put together a simple chart like this and do a simple analysis of your plant and find out where do you have your modes, where are your problems at, and that's going to help you find out where should you start by looking at what type of technologies. And the short answer is you probably need a little bit of all of them, but you probably want to start with one or two. Typically, vibration and thermography is where most people start because that's where your biggest problems typically are. So how do we start up a program? We've already talked about this, so again, this is a review. To start up a program, we need to start small and grow. A little bit of planning is going to be you need to have some goals. You need to have some metrics, because 6 months, 9 months, a year, 3 years, if you don't have some goals, some metrics, how can you prove if you were successful? And think about this, it's not the destination, it's the journey. You never get there. As you see in the image up in the upper right, we start small, we do a few machines, we get some successes that fuels us to grow, and we just keep it growing and growing. Reliability doesn't stop. We can't stop documenting the saves, because if we do, then cost saving measures are going to cancel a reliability program. So we have to keep this going. Start small and grow. So how do we do that? Well, there are some simple tools. You don't have to have a high-end complex program to get this going. You can start by using simple Excel spreadsheets, then move on to some easy to use CMS programs. So here you can see the first step is to create a criticality list, and you basically just list all of the machines in your plant and you sort them by criticality that you assign, not somebody else. The second step is, after you have this criticality list, you get a sum of your machines and find out which machines, based on safety, production, repair, environmental impact, whatever is important to your plant, and you can see the overall numbers that this turbine generator is your most critical, but yet you've got a lot of boiler feed pumps that are pretty critical as well. Based on this rank analysis list, now we can go out and set up a schedule, and you'll see that the turbine generator is going to need more frequent and more constant attention, and the boiler feed pump will need quite a bit, but the ones down at the bottom may only need quarterly or annual reviews. So this helps you get control of your plant and find out where to start. All right, step number 2, what technology do we start with? Well, if you think about it, we don't want to get just the electrical tools, and we don't want to do just the thermal tools. We need a little bit of mechanical tools as well. So again, look at your expected failure modes. The electrical tools are going to be looking for electrical problems that we see in the drive input, in the drive output, and the mechanical tools are going to find problems with the rotating components, imbalance, misalignment, looseness, and bearings. While thermal is going to help us kind of overview both areas, because it's going to help us look for electrical fault problems, overheated bearings, and tank levels. So we really need to look at our expected failure modes, find out where we want to fix, and then get the tools that match that expected failure mode. And then the final thing, we've already introduced this, data overload. If you have a lot of data, it's like looking for a needle in a haystack. The needle is the answer, the haystack, the hay is all of the data. And just adding more data doesn't help you find, so adding more hay to the haystack doesn't help you find the needle. So we need to find answers in all of that data. So how do we do that? Well, there's 3 different ways we can do that. Number 1 is by looking at the report from the tool. We need to get answers from our tools, not just a bunch of data. Number two is we need to start sharing that information amongst our tools. And an example of that is Fluke Connect, where we take all of the answers from our Fluke tools and share it on one common report. And then finally, let's bring it together into a CMMS program. Let's start looking. So again, start small and grow. Start with the individual report, then moved into a shared report. And then once you do that, now we want to look at it as a plant-wide thing to start getting information about how many machines and which machines need to be looked at. Okay, so we've talked about a lot of things over the past 40 minutes, and I hope that we answered or at least got you thinking about some good things. We started by answering you some tough challenges, some tough questions at the beginning, and at the end, I hope we gave you some good solutions that came from some of our customers that have been successful implementing programs. Let me turn this back over to Lori and see what kind of questions we have.
Thanks so much, John. I'm going to ask the quickest and the most important question first that we got, and it was also the first question. One of our attendees said, "Go Navy," and wants to know if you worked on submarines.
Well, the answer is yes and no. I was actually a submarine volunteer because I was in the nuclear power program, but and I did go to a nuclear power prototype in Idaho Falls, Idaho. But no, I was on surface ships. I was 4 years on a cruiser and 4 years on an aircraft carrier. But I did visit a couple of submarines over the years, and I did do some training and some visits on a couple of submarines, but no, I was a surface sailor. So
Okay, thank you. One of the questions, I know we had pictures of Fluke tools and stuff, obviously, in the presentation, and I think I know the answer to this question, but are there third-party screening tools available other than Fluke?
yes, absolutely, and
Yeah.
and you're right. Even though we show the Fluke tools, there are a lot of other tools out there, and as we move along, so of course, we're always going to start with talking about Fluke tools, but yeah, there's plenty of other tools out there. And even though our Fluke Connect right now only brings together the Fluke tools, we are already working on finding ways to bring the results from other tools into our programs. Lori, do
Right.
you have anything else to add on that?
No, that's it. Yeah, and actually, there are some SCADA data and things like that that are already being implemented using some of the software we have. So, but yes, that is the ultimate goal: is we can work with any tool, any software. So, the next question is, as opposed to strictly calendar-based maintenance, do you have any experience with runtime-based preventive maintenance? This person uses runtime meters to generate a good percent of their preventive maintenance work orders.
Oh, yes, that's a good idea, because you're right. Just basing this base totally on calendar isn't the whole answer. Adding, so you can add several different components into there where you can add in the calendar, which is based on manufacturer recommendations. You can put in runtime. You can put in history. Um, but the downside is even putting in a lot of these other factors like runtime, calendar, history, we still find that a lot of machines still fail in a random nature. And I think that the more factors we add and the more analysis we do, I think we're bringing that number down from 15%, which is really low, to a higher number. But I don't know if I've seen any studies that have shown that number gets better from 15% if you just do purely calendar based on rotating machinery, or if you add in runtime, or if you add in history, or if you add in other factors. But I think that there is still a lot of randomness that you still need to throw. Condition-based maintenance is still the best way to know whether a machine. Now, I'm not saying this is good for all machines either, because also keep in mind best practices means we need to look at all machinery. And there are some machines, for example, some of our redundant or basically our throwaway motors and pumps and fans that aren't cost effective to spend time trending or monitoring over time. And so in that case, a planned maintenance by using either a calendar or runtime, those are perfectly acceptable and probably preferred because on a lot of your small considered throwaway or non-critical or non-vital, non-important machines, we don't want to spend time monitoring where runtime is probably the perfect application. So sorry if I ran on a bit and went all over the map on that, but no, that's a great idea.
No, I don't think you ran on. That was great information, John. Thank you. This one's pretty specific. Are there any condition monitoring tools appropriate for pneumatic and hydraulic cylinders?
Oh, that's a great question. As a matter of fact, 3 or 4 years ago, we had a hydraulic study, and what we found out was that several of our tools um, will overlap and will support the hydraulic industry and hydraulic tools in that, for example, if you think about the hydraulic pump and the motors and the rotating components that are part of the hydraulics, vibration and motor testing are all going to be applicable. The question is there a hydraulic tool specifically that addresses condition monitoring of the hydraulic component itself? There are some out there. Fluke doesn't really specialize in that, but there are some companies that do some of that testing, and I don't remember enough. That test was 2 or 3 years ago, but yes, there are some tools that can be used. I'm not sure if they have evolved to a state yet where they're what I would consider a smart tool like we do with vibration and thermography and motor testing, but there are hydraulic type tools out there. They may be a little bit more in the advanced troubleshooting, and maybe we don't have a smart automated tool yet, but maybe that's something we should look at.
Thanks, John. Um,
Mm-hmm.
you mentioned briefly oil analysis, and someone wanted to know if you know of a wireless way to accomplish fluid analysis. You know if there's any technology like that out there?
I don't think that we've got to a point yet where we have a wireless oil sensor, but I think that it's going to get there. So if you think about it, we start with thermography and motor testing and vibration first because those are going to handle the largest volume of machine applications. And so already, now that we're starting to implement wireless vibration sensors, and they're hitting the market pretty hot and heavy right now, and we're starting to have thermal wireless sensors, and we're starting to have electrical wireless sensors. I think that the next step is going to be, ultrasound and oil analysis, because there are some wired oil analysis systems already. There are, but typically those are for your higher end, very critical gearboxes and turbines and that kind of stuff. We are starting to see some wireless modes in that you would have some oil sensors that are wired to a transmitter, and then it wirelessly transmits that to the network. So it's getting there, and I think it's going to be there. But as far as I know, I don't think we have any like wireless oil sensors like we do with vibration and thermography right now.
Okay, thank you. The next question, I think I know the answer for the sensors, but I don't know for the wireless handheld tool, so I'm going to ask it of you. Are the vibration sensors, and then I'm going to add the wireless tools, ranked for hazardous environments such as Class 1, Group D, Division 2 for the oil and gas industry?
That's a good question. So the answer is right now, I don't think any are, but I think that that's something that's going to be coming out. And like with the portable tools, again, it's a cost versus benefit. And any time that we do intrinsically safe, there's a certification process that we then need to have. We need to roll into the unfortunately, that cost then has to be rolled into the product. And so what we've seen a lot in the portable tools is that you end up having to pay 50% or 100% more for a intrinsically safe tool, and in the process we have to turn off a lot of the features, and so you're paying more for a tool that does less. So I think that there are some intrinsically safe um, portable tools. Not all tools are intrinsically safe, and some of them have different classifications. So it's of course easier to get it for a easier classification where when you get into a true intrinsically safe, that's when you really have to pay more for something that does much less. And a lot of people find that it's easier just to get a hot work permit. But I don't think the wireless sensors have got there yet. And again, it's just going to have to get to the point where it becomes cost effective for vendors to start doing that. And so I think that's something that once we start seeing the application starts getting to be big enough, that vendors are going to have to start building the intrinsically safe tools for those applications. So not yet, but I think it's going to get there.
Great, thank you, John. The next question is, are any vibration monitoring with other sensor technologies used for aviation?
I think there are some out there. It's not something that I'm familiar with. Um, but maybe that's something we might want to have to look into. So I hate to say, but the answer I think right now is I don't know. But maybe we can look into that and find out for you.
Okay, thank you. Um, the next question is, I know you speak to the point that electrical, mechanical, and thermal need to be used together. The question is, can you provide some of the reports that show what are the relevant points, I guess, to measure and how they relate to each other in selling the story of fault detections? That was a lot.
Yes, yes. Well, I don't have any with me right now, so I think that's something that we'll probably have to do offline. But yes, we definitely can give you some sample reports on vibration, thermal, and electrical to show how the best way that I put it is that you can find some mechanical problems with electrical tools. You can find some electrical problems with mechanical tools, and you can find electrical and mechanical problems with thermal tools. But if you want to diagnose the fault of a mechanical fault, you need a mechanical tool to diagnose it. So you can find a mechanical problem with a thermal and electrical tool, but you're not going to be able to diagnose the root cause. You need a mechanical tool. And the same thing with electrical. You can use a thermal or a mechanical tool to find an electrical fault, but to diagnose the root cause and correct the problem, you need an electrical tool. So there is some overlap between the three for screening and supplementing, but to diagnose it, you actually need a tool that specializes in that one technology. So maybe what we can do is we can put together some reports from each of those and some information, and we can send it out to people that ask for that.
Yeah, and we could also, if it's short enough, we might could also include some of the information in our blog posts we'll answer any questions we don't get to in a blog post in the next week or two, and we can include that information there as well.
Okay, good.
Let me see. We had a specific question about the 810, and again, I think I know the answer to this. The 810 is one of the vibration tools for those on attendees who don't know, and they wanted to know how it connects to Fluke Connect. And it doesn't, correct?
Oh, yeah. So the question is, how do we get the information from the Fluke tools into Fluke Connect? And so our vibration screening tool, our 805 vibration meter, which takes some simple numbers and then we trend those numbers over time, that does go into Fluke Connect. But if you think about it, the trending spectral data is the same as trending a complex thermal image is a little bit tough to do. We want to, so in Fluke Connect, we're going to trend numbers and to be able to look for trends. In the spectral data from an 810 is like an EKG that a doctor looks at. So where we can trend your pulse and your blood pressure because they're simple numbers, we can't trend an EKG because it's a complex waveform. And the same thing with the 810, and the same thing with other analyzers. We really can't trend the complex FFT spectrum, but what we can do is we can diagnose the complex spectrum, and that's what the 810 vibration tester does, is it diagnoses all the data taken from 3 different axes on the motor and from the pump, and it diagnoses it, compares to a database of hundreds of thousands of machines by vibration experts, and it will give you a diagnostic report that will tell you not what the vibration level is to trend it, but it'll tell you if you have a fault, and if you have a fault, how bad the fault is, and then how bad the fault is, and is it slight, moderate, serious, or extreme, and what is the recommendation and how fast you should act. So that comes in a PDF report, and that PDF can be downloaded and stored into a program like Fluke's eMaint. And so even though, or in any kind, you can transfer by email or anything else. So the answer is, even though we can't trend the vibration numbers, we can take the PDF and we can store that PDF, and then we can look at the PDF from last month and compare it and see the results over time. So I know that's kind of a lengthy way of going around it. So the short answer is no, the 810 can't connect to Fluke Connect because we can't trend the complex spectral data, but you can send a PDF of the diagnostic report to be able to bring up and to be able to look at the results later.
John, thank you so much. I think that is all we have time for today. We are almost out of time. I want to thank everyone for joining us. John, thank you so much for taking the time to put together and present with us today, put together this presentation and present today. There will be a brief survey. Thank you, John. There will be a brief survey displayed on your screen at the end, which will be in just a second. Please answer it and let us know if you'd like to have a copy of the slides that John presented today. Thanks again for joining us, and hope you have a great afternoon.